Okay, let's go through the answers to these questions. So it says a car of mass 2,000 kilograms. So if we just draw our car, this a little bit bigger, and say that it's 2,000 kilograms, subjected to a forwards force of 5,000 newtons and a backwards force due to drag of 1,000 newtons, and it's asking us what will be the acceleration. Okay, now I would think there I'm going to use Newton's second law, RF equals ma, but the reason that's an R in there is because of the resultant force. So the first thing we have to do is say the overall force in that car is the 5,000 forwards minus the 1,000 backwards. So overall it's 4,000 newtons. Put that into the equation. Mass is 2,000 times A. Divide both sides by the 2,000. Gives us A, which is 2, and it's an acceleration, so it's meters per second squared. Similar sort of question for the next one. So we have a bicycle, and the rider have a mass of 200 kilograms. Forwards force from pedaling of 5,000 newtons. Backwards force to drag of 400 newtons. And once again, we're trying to find the acceleration. Newton's second law only works with resultant forces. So a lot of the time, that's the first thing we have to calculate. So 500 forwards, 400 back, give you an overall resultant force of 100 newtons. So 100 equals 200 times A. Divide both sides by the 200, gives us A as being 0.5 meters per second squared. Question 3. Rocket has a mass of 10,000 kilograms. Big numbers this time, doesn't mean we do anything different. Downwards weight of 100,000 newtons and an upwards thrust of 700,000 newtons. And what is the acceleration? Same thing, work out the resultant force first. We've got 700,000 upwards, only 100,000 downwards. Gives us an overall resultant force of 600,000 newtons. Then we can use RF equals ma. So 600,000 equals 10,000 the mass times A. 600,000 divided by 10,000 equals A. So A is 60 meters per second squared. Question 4, a little bit harder. When a forwards force from the engine is 12,000 newtons, that produces an acceleration of 2 meters per second squared. The drag, the backwards force on the bus is 2,000 newtons. What is the mass? It's actually not that much harder. Once again, work out the resultant force first. 12,000 forwards minus the 2,000 backwards gives us 10,000 newtons. Put that into Newton's second law. RF equals ma. 10,000 is our resultant force. We don't know the mass, but we multiply it by 2 as the acceleration. So dividing both sides by 2 then gives us the mass. So the mass is 5,000 kilograms.